Hello all, this is Mr. G, and in this video we're going over a review of applications of polynomial division. So let's not waste any time, let's jump right in and take a look at number one. So number one, it's to simplify the expression, and we've got a standard division problem here. Well, we've got two options. We can use long division or we can use synthetic division. And since we have x minus 3 as what we're dividing by, we can use synthetic division. There's no lead coefficient besides a 1. There's no power of the x besides 1. So here we can just divide synthetically. So we're going to put the real root rather of the x minus 3, which is positive 3, outside. And then along here, we put the coefficient. So 6x squared, we've got 6. Negative 7x is negative 7 and negative 33 is our constant. And I'm going to make sure we've got no missing terms, x to the second, x to the first, and the constant, no missing terms. Now we just run through our synthetic division. Oh, we don't need that x there. Just negative 7 is good enough. All right, we bring down our first number, which is 6. Then we do 3 times 6 is 18. Put that right here. Now we combine and get a positive 11. 3 times 11 is 33, and we combine and get 0. So that's the remainder of 0, which means 11 is the constant and 6 is the linear term. So the answer would be 6x plus 11. Let's check the answer, and we're good. Number two, it's another division problem, but here we cannot use synthetic division because we've got a 2x. We've got a 2 as a coefficient, which means we have to use long division. So let's put 2x plus 3 out here, and we're dividing that into 2x to the third minus 15x squared minus 29x minus 3. We just drag that across, and let's get dividing. So what do we multiply 2x to get to 2x to the third? Well, that's missing an x squared. So x squared times 2x will be 2x to the third. X squared times 3 is plus 3x squared. And then we change our signs. Here we make them both negative, and we're ready to combine. Let's see, that just cancels out, which is what we always want to happen. Here this becomes negative 18x squared. And then we bring down the negative 29x, and then we just repeat the process until we're done. So now it's okay, what do we multiply 2x by to get it to negative 18x squared? Well, 2 times a negative 9 will get it to negative 18, and x times x will get us to an x squared. Now we multiply. Negative 9x times 2x is negative 18x squared. Then negative 9x times 3 would be a negative 27x just to the first power because the 3 doesn't have an x. Now we change our signs here. They both become positive, and we combine. The 18x squareds go away, and here we're left with a negative 2x. Bring down the negative 3, and we repeat the process, hopefully for the last time. So 2x times what gets you to a negative 2x? Well, that's a negative 1. And we multiply. So negative 1 times 2x is negative 2x. Negative 1 times 3 is negative 3. Then we change our signs. Here they both become positive again. And combine. Now let me scroll down slightly. Here we just get 0. So there's no remainder, which means that's our final answer. The answer is x squared minus 9x minus 1. Let's check it. All right, excellent. Number three, another division problem. Here we're allowed to use synthetic division again because the x doesn't have a lead coefficient besides 1 and the power is 1. So we put the real root of what we're dividing by outside the synthetic division, and then we put our coefficients going across the top. So x to the fourth, the coefficient is a 1, and here, this is important to notice, we're missing an x to the third here. So we have to put a 0 for the x to the third. Then x squared is a negative 10, 26x is 26, and 11 is the constant. We just bring it down. It's really, really critical that we noticed this that 0 for the coefficient of x to the third because there is no x to the third here. That's really important. So whenever you're going to use synthetic division, make sure you look to see if there are any missing terms. So we bring down the 1. That becomes 1. Negative 4 times 1 is negative 4. Combine that and get a negative 4. Negative 4 times negative 4 is negative 16. Oh, positive 16. That would have been bad. Let's make that a positive 16. Combine them, get a positive 6. Negative 4 times 6 is negative 24. Then negative, oh no, we got to combine here. I'm getting distracted here. So that becomes a positive 2. Negative 4 times 2 is a negative 8. And we get 3 as our remainder. So since 3 is the remainder, that means 2 is the constant, 6 would be the linear x to the first, negative 4 is the quadratic, that's x squared, and 1 would be x to the third. So the answer would be x to the third minus 4x squared plus 6x plus 2 plus 3 over whatever we were dividing by, x plus 4. And we check our answer, x to the third, negative 4x squared, 6x, 2, and the remainder. Excellent, very good. Number 4, another division problem. Here we can use synthetic division again. So let's jump right in. Let's put the real root of negative 6 out there. And then across we've got our coefficients. I don't see any missing terms to the fourth, third, second, first, and constant. So we just put the numbers right across. 8, 49, 5, negative 3, and 8. Bring down the 8. So 8 comes down. Negative 6 times 8, that's a negative 48. Combine that, get a positive 1. Multiply, get a negative 6. Put them together, get a negative 1. Multiply, get a positive 6. Combine there, we get a positive 3. Multiply, and we get a negative 18. And looks like we're getting a remainder of 10. So what would that be? So if that's the remainder, 3 is the constant, x to the first, x squared, and 8x to the third. So it's 8x to the third plus 1x squared, or just x squared, minus x plus 3 minus 10 over x plus 6. That's how we do our remainders. Check the answer. 8x to the third, x squared, minus x plus 3 minus the remainder. Excellent. Very good. Moving on to number 5. All right, finally, it's a problem that's not just standard division. So let's see. Is x minus 2 a factor of the polynomial? All that. Show your work to justify your answer. Okay, so we can't just put yes or no here. All right, if something is a factor, that means when we divide it, it should be divisible. That means the remainder will be 0, or there essentially is no remainder. So let's just divide these and figure out if it's a factor. So we can put the real root out there again because we've got a lead coefficient of 1 and a power of 1, means that we can use synthetic division. And then across we put a 1 for the x to the third, negative 2 for x squared, 3 for x, and 6 for the constant, and no missing terms here. 3, 2, 1, constant. Very good. Bring down the 1. 2 times 1 is 2. Here we get 0. 2 times 0 is 0. 3 times 0 is 3. Or 3, did I say 3 times 0? 3 plus 0, my bad. And 2 times 3, we get 6. So I'm getting a remainder of 12. Which means these are not going to be factors. So the answer should be no. And we got that one correct. Let's take a look at number 6. Sort of similar to the last one. Oh no, so they use the word factor, but it's actually pretty different. It says the polynomial 2x plus 3 is a factor of this bigger polynomial, and then we've got to write the complete factorization of that bigger polynomial. All right, so this is a factoring problem, and they're actually making this easier for us. They're giving us the first factor. So I'm going to put 2x plus 3 right on our answer line immediately, and then we just have to sort of figure out, okay, what comes next? Well, like we said in number 5, if something's a factor, that means when we divide it, it will be, or rather, it's divisible. There will be no remainder. So let's divide and see what we can get. We can't use synthetic division because of that too, so we're going to have to use long division here. It's 2x plus 3 times 2x to the third, or did I say times, being divided into 2x to the third minus 7x squared minus 3x plus 18. Let's make that look more like an 8. And we bring our division line across, and then we're going to do long division. All right, let's see. So what do we multiply 2x by? That would be an x squared. X squared times all this becomes 2x to the third plus 3x squared. Change our signs, and we combine. Those cancel out. Here we're left with a negative 10x squared. Bring down the negative 3x. And, oh, it's not time to change signs yet because we got to figure out what are we multiplying by. So what times 2x gets us to negative 10x squared? Will that be a negative 5x? Because negative 5 times 2 is negative 10. And x times x is x squared. Then negative 5x times plus 3, that's a negative 15x. Now we change the signs. That becomes positive. This becomes positive as well. and those go away. This becomes a 12x. Bring down the plus 18. And what do we multiply 2x by to get to 12x? Well, that's plus 6. And hopefully we will get no remainder here. 6 times 2x is 12x. And then 6 times 3 is plus 18. Good, because when we change our signs, we're going to get no remainder. I guess I could have stopped right there, but I'm going to show all my work just for completeness sake. So basically, we know this polynomial is going to equal 2x plus 3 times x squared minus 5x plus 6. So that's a factorization of this big polynomial. This, what is this, a power of 3? This cubic polynomial. But the problem is they don't want just any factorization. They want the complete factorization. So we've got to look at this trinomial and see if we can factor it any further. So tell you what, let me erase this. I'll tell you what, yeah, it's fine, whatever. We'll just erase it and factor it. So x squared minus 5x plus 6. How can I factor that into two binomials? Well, the x's are going to be in front, or rather there will be x's in front. And we're looking for two numbers that multiply to get to a negative 6 and combine to get to a negative 5. Did I say negative 6? I meant positive 6. Whatever, we'll just keep rolling. What two numbers would do that? Well, a negative 3 and a negative 2. 6s and 5s always screw me up because it could be 1 or 6 or 2 and 3. A lot of options there, but let me double check myself. Negative 3 times negative 2, that's a positive 6. And negative 3 plus a negative 2, yeah, that gets us to the negative 5 we want. And now we have our complete factorization of the polynomial. Let's check the answer before I forget to do that. 2x plus 3, x minus 2, x minus 3. Okay, I put them in the different order, but it's still completely correct. Number 7, same type of problem. They're giving us one factor, the x plus 7, and we've got to write the complete factorization. So right away, I'm going to put our first factor, x plus 7, on the answer line. And now this one's actually going to be easier because we can use synthetic division. So I'm going to put negative 7 out here, outside the synthetic division. And then going across, are there any missing terms? No. So 1 for the x to the third, 7 for the 7x squared, negative 1 for negative x, and negative 7 for the constant. Bring down the 1, multiply, get negative 7, combine and get 0, multiply and get 0, combine, get negative 1, and negative 7 times negative 1 becomes a positive 7, and we get no remainder, which is good. If we had gotten a remainder, that means we would have made a mistake because they told us specifically it's a factor. So now we got to translate this. Well, if 0 is the remainder, negative 1 is the constant, 0 would be the x to the first, and 1 would be the x squared. So we can rewrite this as x squared minus 1. And I think we can still factor this even further. Oh yeah, we've got difference of squares here. Because we've got two terms, we've got an even power, 1 is a perfect square, and we've got subtraction. So we can put x in front, and then 1's going to be a plus, 1's going to be a minus, and what's the square root of 1? Well, it's just 1. So that's going to be it. It's going to be x plus 7 times x plus 1 times x minus 1. And we'll check the answer. X plus 7, x plus 1, x minus 1. All right. Number 8. Is the polynomial, all that, divisible by x minus 2? Show your work to justify your answer. Okay, so here we just have to figure out if it's divisible. So essentially divide it and see if there's any remainder. If the remainder is 0, then they are divisible. We're dividing by x minus 2, which means we can use synthetic division, put the positive 2 out there. And what's going across? Oh, there's a missing term. There's a missing x squared. So x to the fourth gets a 1. X to the third gets the negative 2. And then x squared is missing, so we have to put 0 there. And where was I? 5 is next for the linear term. And the constant is just negative 10. Again, they're trying to trip us up with that missing term, but we did not fall for that trap. Bring down the 1. 2 times 1 is 2. Combine, get 0. Multiply, get 0. Combine, get 0 again. 2 times 0, still 0. That becomes a 5. 2 times 5 is negative 10. Oh no, positive 10. Oops. That would have been a bad sign mistake to make. Because 2 times 5 is positive 10. Then we combine and get 0. I guess that wouldn't have been the worst mistake to make, because if I'd accidentally left that as a negative 10, I would have saw the remainder of negative 20 and realized I made a mistake, then gone back and checked myself and found that error. What were we doing here? Oh, is it divisible? Oh, the remainder 0? Yeah, divisible. Excellent, very good. Number 9. The polynomial 3x squared plus ax minus 8 where a is a constant, is divisible by x minus 4. Okay, divisible means the remainder is 0 when we divide, and we're going to find the value of a. So we're looking for a, and they're talking about divisibility here. So let's divide, and we can use synthetic division because it's an x minus 4. It's just an x plus or minus a constant. So why did I put the x there? Let me erase that because we're not doing long division. We just need the real root of 4 out there. Let's divide synthetically. So x squared, it's a 3. The linear term, the coefficient is a, or rather what's right in front of x is a. And then the constant is negative 8. No missing terms, right? X squared, x constant, so we're good. Bring down the 3. Multiply 4 times 3 is 12. Add these together and get a plus 12. Multiply 4 times a plus 12. Well, 4 times a is 4a. And 4 times 12, that's plus 40 and 8, so 48. Then we combine and we get 4a plus 40, combining those like terms, and that's our remainder. Now, how are we going to use this to find a? Oh yeah, they tell us it's divisible, which means the remainder has to be equal to 0. So we can just set up an equation here. So 4a plus 40 equals 0, and then we just solve. Take away 40 from both sides. We get 4a equals negative 40. Divide everything by 4 to get a by itself, and we get a equals negative 10. Excellent. Moving on to number 10. Oh, no, number 10. There it is. Very similar to problem to the last one we did. It says if n is a constant, what is the value of n such that the remainder of this division problem is 29? All right, so let's start dividing. Oh, and we can use synthetic division because it's just x plus or minus a number. Here the real root would be negative n, and we're going to divide that by, or rather it's going into, I should say, x squared has a coefficient of 1, x has a coefficient of 2, and the constant is 5. And as always, we double check, no missing terms, x squared, x to the first, excuse me, and constant, so we're good. Bring down the 1, negative 1 times 1, well, that's just negative n. Let's make that look more like an n so we can actually read what I'm writing. Then we combine these and get negative n plus 2. Okay, then we multiply negative n times negative n. That's going to be positive n squared. And then negative n times 2 is negative 2n. Then we combine here and get n squared minus 2n plus 5. And that's the remainder. Now it's not divisible this time because they're saying the remainder is 29. So essentially that equals 29. Let's set it up. N squared minus 2n plus 5 equals 29. And well, this is just a quadratic equation. We know how to solve these. Take away 29 from both sides, which gives us n squared minus 2n minus 24 equals 0. And here we're just going to either factor or use the quadratic formula. Factoring is usually faster, so let's try factoring. Let's see if it'll work. N and n, looking for two numbers that multiply to get negative 24 and combine to get negative 2. I think that's going to be 6 and 4, so negative 6 and a plus 4. Multiply those two, negative 24. Add them together, negative 2, so we're good. And then we know how to use the zero product property at this point. You can probably skip these steps, but I'm going to show all my work. We set one equal to 0. We set the other equal to 0. Here we add 6 and get n equals 6. Here we subtract 4 and get n equals negative 4. So 6 and negative 4, we check the answer. That's not what I wanted. 6 and negative 4. All right. Number 11. How many more are there? I got to start making these reviews shorter. Jeez. All right, number 11. You didn't need to hear that, but we continue. The function f of x is a cubic function such that the real roots of f of x are 3, negative 2, and 9. Which of the following statements is true? Select all that apply. And they're giving us a bunch of like f of a number equals another number. All right, so let's look at the clues they're giving us carefully. All right, they're giving us real roots. That's actually really important. So they're giving us the real roots x equals 3, x equals negative 2, and x equals 9. Now remember, real roots is another way of saying the x-intercept. So all of these points, so 3, negative 2, and 9, they're all going to be on the x-axis, which seems like it might not help us, but actually it's actually really critical because each of these points is going to have a y value of 0. So essentially this x equals 3 gives us the coordinates 3, 0. which we can sort of translate that into, okay, f of, what was the x value? Well, f of 3, that's going to equal 0. And same thing here, f of negative 2 would equal 0, and f of 9 would equal 0. That's what a real root tells us, because essentially when we say f of x, we're saying, okay, what x value are we giving the function? And this coordinate tells us if we give the function an x value of 3, it's going to give us a y value of 0 back. So 3, 0, f of 3 equals 0 essentially mean the same thing. Then let's just see which one of these choices match. All right, well, A matches because that's f of 2 equals 0. B, that doesn't match any of the ones we have. C doesn't match. D doesn't match. E doesn't match. And F does match that one. F of 9 equals 0. So it's, I don't know what happened there, but we'll just get rid of that. And we're back to normal. F of 9 equals 0, so it's A and F. Those are the only choices, right? Yeah. A and F. And we're correct. Excellent. Number 11. Oh, goody, there's a part B. The function f of x is a cubic. Oh, those are the same directions. Why am I reading that again? So what is the sign of f of negative 1? Oh, there's supposed to be a times there. Let me fix that. So what is the sign of f of negative 1 times f of 2? Explain how you arrived at your answer. All right, I can think of two different strategies to use here, and I'm going to show you both. So the first uses the fact that the real roots always give you factors of the function. So we could write an equation for this function. F of x equals 3 would give us the factor x minus 3. Because remember, if we set that factor equal to 0, x minus 3 equals 0, then added 3 on both sides, that would get us to x equals 3. That's something we need to know from earlier in this chapter. Now that that's gone, what was the next real root? Okay, negative 2, that would give us x plus 2. And 9 would give us x minus 9. Now we can find f of negative 1 and f of 2, because for f of negative 1, which I'll do in green, I guess, we just plug in negative 1 for x. So this is going to be negative 1 minus 3 times negative 1 plus 2 times negative 1 minus 9. And let's see what that comes out to. That's negative 4 times 1 times negative 10. Which is going to equal a positive 40, which really we only care about the sign here. They're asking us what the sign is, like essentially whether it's positive or negative. So really we only care that this is a positive number. Now we're going to do f of 2. F of 2 will equal, we're plugging in a 2, so x minus 3 becomes 2 minus 3. The next one becomes 2 plus 2. And then 2 minus 9. Then we simplify. 2 minus 3, that's a negative 1. 2 plus 2 is 4. And 2 minus 9 is a negative 7. Multiply that out, and we get negative 7 times 4 is negative 28 times negative 1 is a positive 28. So essentially, we have two positive numbers, and if we multiply two positive numbers together, we'll get an answer, or an answer that has a sign that is positive. Let's check the answer. Excellent. But that's not the only way we could have found this answer. I'm going to show you another method that doesn't even use an equation at all. What we're going to do here is we're going to use the fact that these real roots are on the x-axis, and we're going to draw a makeshift graph here, sort of a sketch of the graph. It's not going to be perfect. So we've got x equals 3, which will be right here maybe. X is negative 2, and then x is 9. Now, we know it's a cubic function, which means there's at most 3 roots, and they're giving us every root here. So that means we have a pretty good idea of how this looks. Essentially how the graph is going to look. We can narrow it down to two different possibilities. It's either going to start down and end up, or it's going to start up and end down. But we'll deal with this one first. So let me think. I guess I don't need that x equals 3. Let's get rid of that. We're looking for the sign of f minus 1 times f of 2. Did I say f minus 1? It's f of negative 1. My bad there. All right, so what do we do here? So negative 1, that's going to be right here. Let me do this in green so it stands out. So negative 1 would be right there, which means f of negative 1, the function's right there. Now, we don't know what that number is, but we know the sign's going to be positive. And then f of 2, that's going to be, what was this? This was 3. Let me write that in so I don't forget that. That was 3. And this was Oh yeah, this was a -2. See, this is why I should have just labeled this. Now I'm getting confused. All right, now that this is all labeled, I've got the -1 there in between 0 and -2, so that does hit a positive. Then we've got 2, which would be in between the 0 and 3, maybe like right there. And that's going to hit the function also at a positive. So positive times positive would give you a positive for your answer. But that's only one possibility for this graph. The other possibility, which I'll move this out, let's get rid of all this, because it could have been, let me get a red, it instead of starting down, it could have started up and been something like that. Now, will that give us the same answer? Hopefully it will. Otherwise, this has all been a waste of time. So -1 is going to be right here between 0 and -2. Hits the function there. That's a negative. 2 will be right there between 0 and 3. Hits the function there. That's going to be a negative. Negative times negative gives us a positive. So we get the same answer either way. Number 12. For some unknown function q of x, q of 6 plus 3 equals 3. All right, that's probably important. I'm going to copy that right here. Q of 6 plus 3 equals 3. From this fact, we can determine that q of x has at least one linear factor. What could that linear factor be? Explain how you arrived at your answer. Well, what can we do here with this equation? Well, we can take away 3 on both sides, which would give us the equation q of 6 equals 0. Oh, and this is actually really important. That's giving us a factor, excuse me, that's giving us a, not a factor yet, but a coordinate of 6, 0. The x value is 6, the y value is 0. So that's on the x-axis. This is a real root. And a real root gives us a linear factor. So it's going to be x equals 6. And if we sort of undo the zero, sort of work backwards, like we were doing the zero product property backwards, that would be x minus 6 equals 0, which means x minus 6 could be a factor of this function q of x. Okay, can we write that so it looks like a 6 though? Jeez. And is that the answer? Yeah, x minus 6. And it does say explain. I'm not going to sit here and like write all this out, but basically I would just sort of explain all the steps I did there. We can take away 3. That gives us this real root of 6. And since x equals 6 is a real root, that tells us x minus 6 needs to be a factor. All right, just a few more to go. We can see the light at the end of the tunnel. Let f of x equal ax squared plus bx plus c, and g of x equal mx squared plus n, where a, b, c, m, and n are real numbers. The equation f of x equals g of x has k distinct real solutions. What are all the possible values of k? Explain how you arrived at your answers. All right, so they're asking us for k, so what could k equal? And it's possible values, so there's going to be more than one probably. And what is k though? Oh, okay. So oh, all right. So it's saying k distinct real solutions. Here's the equation though. So it says f of x equals g of x has k distinct real solutions. So they're asking us essentially how many real solutions will this equation have? So let's talk about f of x and g of x. Well, f of x is this polynomial right here, ax squared plus bx plus c, and that's just going to be a parabola. Could be opening up, could be opening down. And g of x equals mx squared plus n. Well, that's another parabola. Again, could be opening up, could be opening down. Oh, so they're essentially saying how many intersections are there? Because remember, anytime we have two functions or two functions that equal each other, the solution to that equation will be where they cross. So tell you what, to keep track of this, let's do this in green. We'll do one in blue, one in green, so it's easier to follow. Well, okay, how many times could they cross? Well, we could have the blue one, f of x, going up like this, and we could have this one, the mx squared, or excuse me, the g of x, maybe like this. So that would cross twice. So 2 is a possible value. But what else could g of x be doing? I bet it could cross once. Yeah, I see a few ways it could cross once. One, if it was like sort of the exact same a value, like if a equaled m, but they were just sort of not like right on top of each other, but sort of to the side, so they're only crossing once. So one could be a possible answer. And oh, I guess 0 could be a possibility, right? Because if g of x opened down, oh, I meant to do that in green. If g of x opened down and they were completely missing each other. They're never going to cross. So 0 would be a possibility as well. Let me put those in order. So 0, 1, and 2. I think that's going to be it. I don't know why I have these numbers written in the worst way possible. 0, 1, and 2. That looks a little better. Could it cross any more times than that? I don't think so. Yeah, because it'd have to like curve back to hit one more time. So I think that's it. 0, 1, and 2. Yep, 0 or 1 or 2. Excellent. Oh, did that say explain? Okay, it did say explain how you arrived at your answers. Again, just everything I said there. That's the explanation. You don't need to see me write all that out. All right, number 14. Find all the roots of the function f of x equals x to the fourth minus x to the third minus 5x squared minus 25x minus 750. Well, by using the fundamental theorem of algebra, since the degree is 4, we know that we're going to have 4 roots here. So 1, 2, 3, and 4. Now, we could just use a graphing calculator to find the real roots that there are. And if I remember correctly, there's 2 real roots. I don't have a graphing calculator app on this laptop, but we should be good at that by now. You can just go to desmos.com or something just to find the real roots. And I believe they're -5 and 6. I'm going to double check real quick. Yeah, they're x equals -5 and x equals 6. I just went to desmos.com to use that. So we got -5 and 6. But we all know how to find real roots in graphic calculators by now. And now, what can we do with that? Well, if we have 2 real roots, those are 2 factors essentially. We can divide them out. So essentially, we're saying we can rewrite this function f of x as x plus 5 times x minus 6 times something. And we just have to find that something to find the remaining 2 roots. That's still an ugly question mark, but I'm not doing it 3 times. Whatever. First, let's divide out x plus 5. It doesn't matter which one we divide out first. You can do it in any order you want. So we're going to divide out the x plus 5. Let's bring down the coefficients. 1, -1, -5, -25, and -750. And we divide synthetically, bring down the 1, multiply, get -5. I'm going to do this carefully so I don't make a sign mistake. -6, multiply, and we get 30. Combine, and we get 25. Multiply, and we get... Ooh. This is looking ugly. Did I make a mistake? -6, 30, +25. All right, we'll keep going. Let's see if this works out nicely. So 5 times 5 is 25. Carry the 2. 5 times 2 is 10. All right, 125. Okay. And then we put them together, get -150. All right, at least we know it's a factor. So we know the remainder better be 0. So hopefully the remainder will be 0. These numbers are kind of freaking me out. So we multiply this. 0 comes down. We know it's going to be positive because it's negative times negative. 5 times 5 is 25. Carry the 2. Yeah, we get 750. Okay, good. All right, I was a little nervous there, but just by knowing it's a factor, we can double check ourselves. Oh, I wanted that square there. All right, so now we still have to divide out this x minus 6. So in case anyone's confused by that, I'm going to go through some explanation. You don't need to show all this work. I'm just going to show what this means. So by dividing out the x plus 5, we can say, okay, this original polynomial f of x equals x plus 5 times, and then we're going to bring all this down. So it's the x, what is that? Constant, linear, quadratic, x to the third minus 6x squared plus 25x minus 150. But there's another factor we can still divide out of this. We have yet to divide out the x minus 6. So we're going to take our new polynomial and divide that by x minus 6 using synthetic division. Write the positive 6. Then we've got a 1 for x to the third, -6 for x squared, 25 for x, and -150 for the constant. All right, let's run through it. Bring down the 1, multiply, get +6. We get 0. Multiply, get 0. That's 25. And 6 times 25, that's 30. Carry the 3. Yeah, 150. Good, good, good. So we get a remainder of 0. And then we can turn this into x squared plus 25, which means that question mark we were looking for is x squared plus 25. So we have the complete factorization. It was plus 25, right? I'm going to double check that sign. Yeah, plus 25. We've got the complete factorization. And now, basically, to find these other two roots, we've already got the root for x plus 5. We've got the root for x minus 6. We just have to use the x squared plus 25. And we just use the zero product property. We set that equal to, we set x squared plus 25, forgot the plus 25, set that equal to 0. And here, sometimes we'll need the quadratic formula, but we actually don't here. We're just going to get x by itself. Take away 25 from both sides, we get x squared equals negative 25. Then we take the square root. Oh, and we've got the square root of a negative, which actually does make sense because we found all the real roots. So the other two roots are probably going to be imaginary, and they are. So we get x equals, well, we took the square root of both sides, so we need plus or minus. And let's see, the square root of 25, that's just 5. And the square root of negative 1 is I. Because again, we can rewrite this. Let me do a thought bubble just so I show my thought process. We can rewrite negative 25 as 25 times 1. Times negative 1. And then just take the square root of both. Square root of 25, 5. Square root of negative 1, I. And then we just write it on our final answer line. So it's a positive 5i and a negative 5i. And we check against the answer key. 6, negative 5, 5i, negative 5i. Excellent. And the next problem, we're finished. Thank goodness. Okay. As always, I hope this was helpful. If you have questions, let me know. Good luck studying for your quiz and enjoy the rest of your day.